today's class. In today's lecture, I am going to discuss about examples of type 1. In the previous video, we have discussed about inverse differential operator and particular integral. Okay, in that I have discussed you how to find particular integral, means the complete solution of given differential equation of higher order. Okay, in that I have mentioned there are 5 types of problems to get the particular integral of the given problem. Okay, so now in this class we are going to study how to solve the examples of type 1. What is type 1? Type 1 examples are of the form e raised to ax divided by f of d form. Okay, in the last class I have discussed, just go through the those 5 types. Okay, now first example, solve 6 d square y by dx square plus 17 dy by dx plus 12y equal to e raised to minus x. Okay, solution. We'll solve this. In the last video also I have explained the procedure, working procedure. What was that? Uh, we have to consider this d square y by dx square means dy by dx as capital D. Already I have explained this. There we have considered d by dx as capital D. Then if it is d, then d square by dx square will be d square, capital D square, and so on like this. Okay. So now we use this. We have write in that form. In place of d square by dx square, I am going to write 6 d square. Okay, plus 17 d plus 12 into 1. Okay, this is equal to e raised to minus x. Once we have converted this in this form, the given differential equation, then we have to write the auxiliary equation. Auxiliary equation means what? In place of d, we have to write m. Okay, then the auxiliary equation is, what is that? 6m square plus 17m plus 12 equal to 0. Such type of examples I have discussed in the starting videos. Okay, just go through them. Or what you may say this as, or you can write this as 6m square. Then we have to factorize this. Okay, now this can be expressed as 9m plus 8m plus 12 equal to 0. You know the factorization. Okay, now take down the common factors. So how you write? So here 3m, 2m plus 3, and here you can take, then it is 2m plus 3 equal to 0. So then you have two factors, 2m plus 3 and 3m plus 4 equal to 0. So this gives us 2m plus 3 equal to 0 or 3m plus 4 equal to 0. Then what is your m? M, it is minus 3 by 2 and minus 4 by 3. Okay. Once you get these roots, then you can, using these roots, you can write which solution? You can write the complete solution, that is yc. Therefore, yc is equal to which type of roots these are? Both the roots are what? These are m1 and m2 are real and distinct. Okay. So when the roots are real and distinct, what is the root solution? Complementary function. It is c1 into e raised to m1x plus c2 into e raised to m2x. So now m1 is this, m2 is this. So then it is c1 into e raised to m1x. m1 is minus 3 by 2. So minus 3 by 2 into x plus c2 into e raised to minus 4 by 3 into x. Okay, this is your complementary function or complementary solution. Now our aim is to find the particular integral. So as I said in the last class, what is the rule? If your function is of the type particular integral e raised to ax by f of d, then yp. Yp is what? How you write? The given function is what now? E raised to minus x. Okay. So RHS is e raised to minus x. What is your function f of d? F of d is divided by f of d. Okay. 6d square plus 17d plus 12. This is our function. What is the rule? If the function is of this form, then we have to substitute a in d in place of d. What is a here? What is the standard form? E raised to ax. What is a? A is minus 1 here. Okay. So this becomes e raised to minus x divided by 6 into minus 1 square plus 17 into minus 1 plus 12. If you want, where d is equal to a is equal to minus 1. So what happens now? It is e raised to minus x divided by, it becomes minus 1 whole square is 1. So 6 minus 17 plus 12. Plus 6 plus 12 is 18. Okay. Minus 17. So it is plus 1. So e raised to minus x divided by 1. So equal to e raised to minus x. Therefore, yp equal to what? E raised to minus x. Now, this is not the solution. Okay. Solution is what? General solution is sum of complementary solution and particular solution. Okay. Hence, y is our solution. Y is y equal to yc plus yp. Y is what? Your general solution, or you may say complete solution is complementary function and particular integral. So complementary function is what? It is c1 into e raised to minus 3x by 2 plus c2 into e raised to minus 4x by 2 plus yp. Yp is e raised to minus x. This is our general solution or required solution of the given higher order differential equation, which is of type 1. What is the type 1? E raised to ax divided by f of d form. Now, we'll solve second example. Y double dash plus 2y dash plus y equal to cos hyperbolic x by 2. So, as I said, we have to write it in the form d square plus 2d plus 1 into y, okay, equal to cos hyperbolic x by 2. It's a hyperbolic function. Now, add the auxiliary equation. So, auxiliary equation is m square plus 2m plus 1 equal to 0. What did it use? This is nothing but what? M plus 1 whole square equal to 0. So, this gives us roots as m equal to minus 1, minus 1. Then what is your complementary function? Y of c is equal to, again, roots are what? These are equal roots. Okay. So, real and equal. So, it is c1 plus c2x into e raised to minus x. This is one solution. Now our work is to find particular integral. So then yp, now you may think in the RHS if we have cos hyperbolic function, how it becomes type 1 example. Okay, type 1 is what? It is of the form e raised to ax divided by f of d. Okay, in the previous video I have mentioned in place of e raised to ax, you may have e raised to ax plus b. If you have a raised to x, then it can be written as log a e raised to log a into x, or you may have sin hyperbolic ax or cos hyperbolic ax. Okay, now how to convert this cos hyperbolic function to exponential form? We have a standard result. What was that? What is that? Cos hyperbolic x can be expressed in the form of in the exponential form. The formula is e raised to x plus e raised to minus x divided by 2. This is the standard formula of cos hyperbolic function in exponential form. Now, what is the difference here? In place of x, here we have x by 2. That's it. Okay. Now we use this property formula and write cos hyperbolic x by 2 in exponential form. Once you write this exponential form, you may write it as 1 by 2 e raised to x by 2 plus e raised to minus x by 2. This is our e raised to ax. Okay, in the type 1 divided by f of d. Okay, f of d is what? D square plus 2d plus 1. D square plus 2d plus 1 is what? D plus 1 whole square. Okay, understood how to write the convert this in a standard form? Now 1 is equal to, keep this 1 by 2 as it is. Okay, now here in the numerator I have two exponential function and I have a common denominator. I will write it as e raised to x by 2 divided by d plus 1 whole square plus e raised to minus x by 2 divided by d plus 1 whole square. Okay. Now it is of the form e raised to ax by f of d, e raised to ax by f of d. Once the function is of this form, what is the next procedure? Next procedure is we need to substitute a in as d. Okay. Now for the first expression, what is a? A is 1. Okay. So e raised to x by 2 divided by d is 1. So 1 plus 1 whole square. Plus for the second expression, what is a? We have minus x by 2. So a is minus 1. So it is e raised to minus x by 2 divided by minus 1 plus 1. Sorry, not 1. It's 1 by 2. 1 by 2. Okay. And here it is minus 1 by 2. So when further, when you simplify, what will you get? Numerator as it is e raised to x by 2. In the denominator, 1 by 2 plus 1 is 3 by 2 whole square plus here e raised to minus x by 2 divided by minus half plus 1 is plus half. Okay. Plus 1 by 2 whole square. Then what you may write? So 1 by 2 into e raised to x by 2 divided by 3 by 2 whole square is what? 9 by 4 plus e raised to minus x by 2 divided by 1 by 4. Okay. Now you may write, take 1 by 2 inside the bracket, and when you multiply 1 by 2 to both the terms, for the first term, what it is 1 by 2. In the denominator we have 9 by 4. I write it as 4 by 9. Okay. E raised to x by plus again 1 by 2 into 4, 4 by 1 into e raised to minus x by. So when you simplify, what will you get? 2 by 9 e raised to plus x by 2 plus 2 into e raised to minus x by. This is our yp. That's particular integral. So now we need to write complete solution. Okay. Thus, complete solution is what? The complete solution is your y. Y is given by yc plus yp. Okay. Therefore, y is equal to yc is what? It is c1 plus c2x into e to the power minus x plus yp. Yp is 2 by 9 e raised to x by 2 plus 2 into e raised to minus x by 2. This is the required solution or the solution of the given higher order differential equation of type 1. This is how to solve the given differential equation of higher order of type 1. Okay, in the next video, I am going to solve examples of type 2. Okay, till then keep practicing. If you have any doubts, please do comment in the comment box. Do share the video link to your other college friends and help them to study well. If you have any doubts, please comment in the comment box. It will be helpful to me. Thank you. Take care.